Okay. And I wrote this plus number 13 for anybody who was doing the warm-up so they know the other one we were going to do, just in case. Okay, second term, an expansion of 2n minus 1 to the fourth. So the fourth power tells me that I'm in the fourth row. So 4 combination something. And the second term is going to be 4 combination 1. Okay, then I'm going to write the front seat thing in parentheses. And then I'm going to write the back seat thing in parentheses. So the 4 comes from here. The 1 comes from subtracting 1 from the term I want. And then I wrote the front seat thing and the back seat thing. The back seat thing is going to have the same exponent as my combination whatever. And the front seat thing has to have an exponent that will add to the total of 4. So it has to be 3. Okay. What is 4 combination 1? I believe it's 4. 2n to the third is 8n to the third. Probably if you made a mistake on this problem, it was right there. And negative 1 to the 1 is negative 1. 4 times 8 is 32 times negative 1 is negative 32. And then n to the third. Okay, flip over to number 13. Okay, we got a natural log problem here. I wanted to do 13 instead of 12 because this was really similar to yesterday's and we have this on our quiz. So I wanted to do 1e and 1 natural log for you. Thanks, Mrs. Taub. It's so thoughtful of me. Okay. So step 1 is to determine the operation. So operation in this problem is division because that's subtraction. So natural log 7 over negative 2x equals 1. Step 1, determine the operation. Step 2 is to decide if it's a Guinan circle or cross out. This is a Guinan circle problem. When you do a Guinan circle problem, you need a base to start with. So I'm going to change this to be log base e. The reason I did, well, these are equal. Log base e is natural log. But the reason I changed it is so that I would have a start for my Guinan circle. So e to the 1 equals 7 over negative 2x. Okay, now I'm going to multiply both sides by negative 2x to get rid of the denominator. So I have negative 2x e equals 7. And then I want to get x by itself, so I'm going to divide both sides by negative 2e. Yes, you can do that in one swoop. You don't have to do it in one swoop. You could divide twice if you wanted to, but I'm too lazy. So now I'm going to go to the calculator. 7 divided by negative 2e. And then the calculator is going to want you to put an exponent in there. So just put the 1. I mean, you had the 1 on there before. You guys should know that e is e to the 1 anyway. Okay, so tell me the proper rounding for this problem. Yes, Negative 1.2876. Also, do you notice how I put the denominator in parentheses because they're both on the bottom? Did you notice that? Anyone notice? No one noticed the parentheses in the denominator. It's just a good idea. I'm just gonna here throw that like that. Okay. We are using the next sheet of dot paper today, so you can find that in your packet. We're going to use the whole sheet for number 65. So just grab the next. So here's yesterday's. Just set the next page aside for a moment. All right, to get ready for more fun 3D graphing today. Super excited about it. I know it's awesome. Okay, but first you must suffer through my agenda. I really like my joke. We'll see. You guys don't tend to like my jokes as much as I do, but we'll see. Okay, we're doing only 3 problems today, and none of them are long or super hard. First one, you guys are gonna have to do some work with the. Did you guys get some coordinates and some scissors on your desk? You should find a little strip of 3 coordinates and some scissors. So that's gonna be number 63. Number 64, I'm gonna remind you how to graph a line with X and Y intercepts. And then for 65, we're gonna actually graph our first plane, which is going to be on dot paper. It's gonna be awesome. Okay, this is my joke, and here's the homework. 68 to 74, skip 73. This says snakes on an inclined plane, snakes on a Cartesian plane, snakes on a 3-dimensional plane, and then snakes on a plane. I like the one coiled up the z-axis. I think that might be my favorite snake. I'm not a snake person, by the way. Snakes and eels, that's just a no for Mrs. Talbot. Yeah, any kind of snake or eel type dealio, slithery, missing limbs, like should be limbs there. What? Yeah, same thing. Legless lizards are snakes. I mean, I trust you, but just in my mind, they're snakes. Okay, snakes. By the way, in my family, we call them snakes, and now you can't unhear it. All snakes are snakes. My youngest child thought that by calling them snakes that they would be less scary to me, but it doesn't work. Now I just call them snakes and they're scary. Anyway, okay, 63. Consider the equation 5x plus 8y plus 10z equals 40. Okay, we kind of discussed this yesterday. What shape does it make? That word was only 4 times in my note. Plane. It makes a plane. Okay, so what type of plane? We're going to see what a plane looks like. We saw that on the 3D graphing tool yesterday. Explain how you decided was because Mrs. Talbot, spoiler, alerted it yesterday, but that's all right. So this is a plane. We defined a plane yesterday. It is a flat surface that goes on forever with no thickness. Okay. I just love that answer. Look at how much I wrote there. So good. Okay. Is the point 4, 5, negative 2 a solution to the equation 5x plus 8y plus 10z equals 40? Justify your answer. Okay, so we're going to do this one together. And then you guys in C are going to do the 3 that I put on your table. So, okay, so come over here. Okay, we're going to plug this in for X, this in for Y, and this in for Z. So 5, X becomes 4, plus 8, Y becomes 5, plus 10, Z becomes negative 2, equals 40. And this is, you can use a calculator when you guys do this on your own, but 20 plus 40 minus 20 equals 40. Okay. Does this make sense? Okay. Now, what does this mean for us when I say something's a solution? It means the point is on the plane. So this coordinate, this 3D coordinate lies somewhere on that plane. Okay, this is what I want you to do for C. I've given each team 3 coordinates. I want you to do that exact same thing in the space for C. I want you to only bring me the true ones. Only bring me the ones that work. Recycle the ones that don't work. Let me say that again. I want you to walk over and hand me over here the ones that work, the ones that are true, where you get like 40 equals 40. If you don't get that, put them in the trash. I want you to cut them and bring me the ones that work. Other ones go in the trash. You guys good? You clear? Okay. Thank you. He's helping me teach inequalities to Math 1. He's an alligator, but I call him Crocky. Oh, someone stole it. You can just go. Oh, I like your sweatshirt, by the way. You guys feel free to use a calculator. Calculators are okay. Thank you so much. Thank you. Thank you.
Is it? Oh, sorry. But we walked through it. Brenda, what happened to you? Stations when you and your umbrella was Asia? I was like, hello. And then we were laughing.
That's it. It's fine.
Where did you get that?
Thank you.
Okay, you guys, once you bring me your points that work, just sit back and relax and watch the Desmos. Yeah.
Wait, is this working? It was my sister's. It was, I think it's because she like wrote a note card and moved on. So she, because I was looking for posts on it and there's a note that was just so funny. Yeah, it was like this. She just gave it to me one day. I was like, oh, you don't need this. It's like, no.
Oh.
All right, you guys, let's see what happens here. So I'm gonna plot all of the slips you gave me, and then we'll see what happens. Maybe I'll do it correctly. I don't know if anything else, it looks cool. All right, almost to the moment of truth. We're gonna see if your math was correct. All right, last one. Okay, what I'm gonna do, those are all the points you gave me. What I'm gonna do is rotate the model, and then we're gonna see, you'll be able to blatantly see if any of them are incorrect. Ah. Okay. Can you guys tell that you guys did a good job? See how they all line up? Okay, now what I'm gonna do, the last thing is I'm gonna type the equation of the plane in, and it should go through all of your points. So the equation of the plane was 5x plus 8y plus 10z equals 40. Look at how amazing you guys are. You did it perfectly. All of your beautiful points are on the plate. Okay, so now what we need to do is learn how to graph the plane without plugging in 50 coordinates, plotting 50 points, and like imagining where it would be. So that's what the rest of the lesson is. And it is just as easy as this, which is good news. Okay. All right, so you guys should have 7C. I don't. Go ahead and set up the rest of this. Great job on the coordinates. All right, guys, so notice there's 4 bullet points next to D. So there are 4 questions that we need to answer for that. They're very quick, don't worry. Okay, these are the 4 questions. Are there any points that you suspect are solutions but do not have a point showing on the graph? Okay, let me show you the picture again. Are there any points that you think are solutions but are not points on our graph? So do you think there are more solutions than these ones here that we plotted? Yes. Okay. How many solutions are there? Infinite solutions. These are great questions. 1-word answers, me liking. Oh, true. You guys are all on space-saving measures in your notebooks. Okay, are there any points showing that you think are not solutions? Okay, so this would have happened if somebody made a mistake in their math. With us, ours looked perfect, right? So we're going to say no, all points are on the plane. Because we did ours perfectly because we're perfect. It's not going to happen to me through all 3 of my classes, just so you know. Okay, last question for D. What shape is formed by the, why do they ask it 75 times? It's a plane. It's a plane. A plane. The answer to the same question over and over and over. Okay. Now, this is the part we need to get to. How do we graph a plane without graphing 100 different coordinates and then just assuming? Okay. How we're going to do this is we're going to go back to math 1 and we're going to practice graphing a line first. And we're going to use that information to graph a plane. Do you guys remember yesterday I said there were 2 different ways to graph a line? There's 2 ways. You could solve for y to get y equals mx plus b, which is what you guys do most of the time. Or you could use the x and y intercepts. That's what we're going to do here. So I need to remind you how to do x and y intercepts. And we're going to do it with the patented Mrs. Talbot cover-up method. Okay, so we're going to graph this line. I'm going to cover up the 5x. What is that doing? It's plugging in a 0 for x, basically. So I put a 0 here. So I cover it up. What is y? Right, y is 5. You guys all tell that y is 5? Because you divide both sides by 8. Okay, what does that mean? That means that there is a coordinate that we can graph at 0, 5. And this is called the y-intercept. Okay, now I'm going to cover up the y thing. What is x? So there's another coordinate we can graph, 8, 0. And we have our line. This is not the way you guys graph usually, but this is the way that works the best for planes. So I wanted to remind you that that was a thing. Okay. Now we're going to do the plane. So what I want you to do before we do the math, I want you to set up your coordinate system. Okay. And try your best to sort of space it like I did because of the way this problem is. I think z ends up being 12 and y ends up being 15. So I counted over 1, 2, 1, 2, 3, 4, 5, 6, 7 dots-ish. This, I think, I don't know. This needs to be more than 12. I think this ends up being 12, like the dot is at 12, so it needs to be more than 12. It doesn't have to be perfect. We'll figure it out. Did you guys make a terrible axes? Oh. All right, you guys. Okay, so let's go do the math so that we can graph it. Okay. So we're going to find 3 points. We're going to find the x-intercept, the y-intercept, and the z-intercept. X-intercept, y-intercept, and z-intercept. This is very simple math, which is great. For the x-intercept, y equals 0 and z equals 0. For the y-intercept, x equals 0 and z equals 0. And for the z-intercept, x equals 0 and y equals 0. So everything's 0 but the thing. Does that make sense? So I want x-intercept, so the other stuff is 0. Okay, so I'm going to plug this in. So 12x plus 4 times 0 plus 5 times 0 equals 60. There are like 75 people in here who are like, can't you just do the Mrs. Talbot's cover-up method for this too? Yeah, you can, but I'm showing how to do it properly. 12x equals 60. That should say 60. I don't know what it says. That should definitely say 60. Divide by 12. X equals 5. Okay, now we're going to write the coordinate properly. 5, 0, 0. Okay, so go to your graph, go to the origin, and go to 5, 0, 0. Do you guys know how to finish this? Yeah. Okay. All right. So y-intercept 12 times 0 plus 4y plus 5 times 0 equals 60. 4y equals 60. Y equals 15. 0, 15, 0. Okay, this might be the hardest part, counting out 15 dots on the y-axis. 1, 2, 3, 4. All right, so I have my x-intercept, my y-intercept out 15. Last one. Okay. Everyone should have 5, 0, 0, 0, 15, 0, and 0, 0, 12. So here's my 5, 0, 0, 0, 15, 0, and 0, 0, 12. Okay, so you graph those 3 dots, and then what you do is you connect them with a ruler. And then I like to take a colored pencil and shade in my plane. You guys can shade with the pencil, regular pencil if you want. There's colored pencils on the table if you want. Again, while you're coloring this, think about the fact that your plane doesn't really, it's not a triangle. The triangle is the part that shows in the first quadrant. It's actually not a quadrant. It's a octant, but it's the part that shows in the positive region, positive, positive, positive region. So you have to imagine that it actually goes on forever. This is just the part that we can visualize on graph paper. This is the best we can do on graph paper. While you're finishing your coloring though, I'm going to type the equation into Desmos. What was it? 12x plus 4y plus 5z equals 60? Okay, one of the things you'll notice about Desmos is that it goes out to like 2. So you might have to zoom in or out, be able to see it properly. But this is kind of the orientation we're looking at it. So if you look here, so our x is going this way, our y is going this way. So if you look up here, this is the part that we graphed, this triangle right here. But this is what it looks like when it cuts through all of the other planes. all of the other planes, all of the other space. So you guys see how we're limited on graph paper. Okay, and you're like, it really doesn't bother me, Mrs. Talbot, because the math is easy. So